My project was the Voltmeter project, and our goal was to create a circuit using LEDs that, when subjected to different voltages, could indicate the value based on the number and types of LEDs that lit up. LEDs, unlike light bulbs, are diodes, which means they're capable of functioning in only one direction, meaning that the positive end, the anode, and the negative end, the cathode, must be attached to the respective sides of the circuit. We found through research and experimentation that the different colors of LEDs represent different classifications that yield different voltage drops. Another element of this project that required researching was learning about how breadboards function. It's important. A breadboard is essentially a circuit builder that allows current to flow horizontally across it. Only by placing something that can transfer this, like energy, to a different row can you get electricity to flow across the circuit. When setting up circuits, it's important to include a resistor because, as understood by Kirchhoff's voltage law, the algebraic sum of all voltages in a circuit must add up to 0. That means that all the voltage output by the power source must be consumed over the course of the circuit and that there's no remaining excess energy. In order to measure the voltage that was put into the system, we hooked a real voltmeter up to the power source that could give us readings of how much direct current was being put into the system. After some experimentation, we found the different amounts of voltage that were dropped based on the different colors of LEDs. So here is a setup of the positive and negative wires attached to a blue LED with a resistor to take in and consume the excess voltage. So this is another picture. This is when we were practicing setting up LEDs in parallel with one another, which we did by splitting the power source into 2 branches with 2 separate resistors. From there, we did some experimentation with different colors and came up with a set of 8 different paths that we could create that had different voltage drops. And here's a circuit diagram of essentially what you see here on the voltmeter. We had to think about lots of things like whether or not each path should have its own resistor. Turns out you needed to because resistors can only resist up to so much extra voltage, or the system might not work because the LEDs blow. And also, by splitting up these paths, if we had them all without any resistance on them, if there's a path without, then it would just take the path of least resistance and none of the LEDs would light up. So this is a video of what you're going to see here. So here is the voltmeter, which is reading how much power is coming from the power source. And as you turn it on, you can see with different amounts of voltage, they light up. So first the red one, which lights up at approximately 1.6 volts, then the blue, and they go back and forth. There's a little bit of inconsistency with in what order, if there's multiple LEDs, they light up, which is also because certain colors of LEDs are a little more responsive. That's basically how it works, and it can read up to about 7.5 volts, and it goes back down. So thank you. Cool, we're done.